because my other class. Yep. So this is page, guys, we're getting started. Out of the book, this is page 669. So if you will, please open to page 669 and look at problem number 16.
672.
Is it 672? So the question, sorry guys, my throat's giving out. The question in the book asks us to find the area of the regular polygon. Now, it's given us some weird measurements up here. We have a diagonal distance of 8 and 4 square roots of 2. Now, this did say this was a regular polygon. What did regular mean?
Equal sides, equal angles.
Yeah. Equilateral. Equilateral and equiangular. Basically what I'm asking is, what shape is in the middle here? Yeah, it's a square. Because it's equilateral, it has to be a square. And equiangular. Equilateral could have just been a rhombus. Equiangular could have just been a rectangle. Gentlemen, just because I have a video on does not mean I won't stop this. Take a little time out to have a talk. Now, this is a square. Because it's a square, we could start looking and saying, okay, well, I know some things about a square. This is a right triangle here with a side of 8, 4 square roots of 2. I could figure out what this other side is by using Pythagoras Theorem. Or if I remembered my properties of a 45, 45, 90, I would also be able to use those. But let's just say we don't remember our properties. So let's just start with Pythagoras Theorem. A squared plus b squared equals c squared. In this scenario, what would a be? In this one right here, which one would be a? Let's call 4 square roots of 2 a. What would be b? Would 8 be b? That's c because that's the hypotenuse. So that leaves df to be b. So a squared plus b squared equals c squared. So that means I'm going to put in 4 root 2 squared plus b squared equals 8 squared. Now, I don't know about you guys, but squaring 4 root 2 is not easy sounding thing to do. So I'm going to do it like this. 4 root 2 times 4 root 2 plus b squared equals 64. So this is what it means to square something. And I know that I can multiply 4 and 4 together and get 16. And I can do root 2 with root 2 and I get root 4. What's the root of 4? So that's 2. And 16 times 2 is how much? 32 plus b squared equals 64. So now, subtract 32 from both sides. And I'm going to get b squared equals 32 again. So I got to root both of them to be able to get rid of the square root. And now we can't forget that this does need to be plus or minus, but since we're talking about lengths in geometry, we don't deal with the negatives. But next year in Algebra 2, you do need to remember that negative. So b equals the square root of 32, which I know is going to be 4 times 8. What's the square root of 4? 2. I can take that out, right? So that's 2 roots of 8. But 8 is just 4 times 2, right? So that's 2 root 4 times root 2. So I can take the square root of 4. What's the square root of 4? It is 2 as well. Okay. So this is 2 times 2 times root 2, 4 root 2. And look at that. Wouldn't it have been easy to just remember our little properties from the beginning? What's the properties of a 45-45 right triangle? Well, it's isosceles. So if one of the legs is 4 root 2, then the other leg is also 4 root 2. That's a nice little property of a 45-45 90 right triangle. Okay. If this is 4 root 2, can I extrapolate and figure out what FC is going to be?
No.
Well, this line EF is called, it's our new word we just came up with today. What's that called? Apothem. That's an H and an M, and I can't get an M to write it. But handwriting is not that great on a smartboard here. So the apothem.
Right.
So the apothem meets at the midpoint of a side. Guys, we're up to 13 already. So it meets at the midpoint of a side, which tells me since it's the midpoint, the left and the right are the same length. So DF and FC are the same. So how long is FC?
4 root 2.
Yeah, 4 root 2. So I'm going to erase this, and I'm going to put 4 root 2. So this distance from here to here is 4 root 2, and this distance from here to here is 4 root 2. Yeah, you add them together. How do you add square roots? If you got 4 root 2's plus 4 root 2's, what do you got? Well, let's use some substitution in here. We're going to substitute the word dog for root 2. Ready? So I'm going to add 4 dogs plus 4 dogs equals. Did I square the dogs? Did I add the dogs? I mean, did I get 4 dogs? No. So 4 root 2's plus 4 root 2's are 8 root 2's. So you don't add root 2 with root 2 and get root 4. You get 8 root 2's. Or another easy way to remember it, treat it like it's an x. What's 4x plus 4x? 8x. You don't change the x. It's not x squared. Okay? So the square root of 2 is just like an x, and you just add the coefficients to get 8. So that total length is 8 root 2. Okay, so now we had a formula that we learned today. I'm going to have to erase this whole part over here now that we've used it and done everything we needed with it. So I'm going to erase this whole part over here. What was the new formula for the area of a polygon we learned today? Yeah, 1/2 perimeter times apothem. What was the apothem in this problem? Yeah, it was this blue line. That's our apothem. Right here. What's the perimeter? Yeah, perimeter is going to be the distance all the way around that shape. Yeah, so we're going to take and do 8 root 2 plus 8 root 2 plus 8 root 2 plus 8 root 2. So that's going to be 32 root 2's, right? So let's add that together. So the area of a polygon is going to be 1/2 of 8 root 2's times 4, because that's what the perimeter is going to be. This is the perimeter here. There's 4 sides at 8 root 2 each. And then the apothem is still going to be this blue line in the middle, 4 root 2s. And I know that there's a lot of square roots going on in here, and that can really mess things up mentally for us. But just try to follow the math and forget about the root 2s. Treat them like they're an x while we're working, okay? So here, I can multiply these in any order I want. What do you want to take a half of? What's easy to take half of? Half of 4, okay. So half and 4 is going to leave me what? 2. So now I can do 8 root 2 times 4 root 2. And I can do that in any order, so I'll do 8 root 2 times 2. And that's going to be 16 root 2s times 4 root 2s. That's right. Now this is 64. Now remember, this is no longer add. Earlier we added 2 root 2s. And I told you that you don't mess with the root 2s when you add. This is multiply. So when I multiply the 16 and the 4, but I also multiply the root 2 and the root 2. And what do I get? Root 4. And do we know what root 4 is? It's 2. So this is 64 times 2, which is 128 units squared. Whew! Is that a mess or what? Yeah, that's a... So, do you guys want to see another transformational way? This is totally different than what anybody would probably teach you, but it's totally cool. I like doing this. Now, let me show you. Let me lock this. So we're going to clear the screen. Everybody's got this. If not, guys, remember, stop it. Let go. I don't want you. I want you to want me. I don't want you to want... I do... What? Sorry. Okay, so here's what I want. What if I cut this up into small triangles? If I cut this like this, since this is a square, this is going to be 8, 8, 8. And I'm not even going to worry about this 4 root 2 thing. Let's just see this. This is like the quick Mr. Conaway way to figure out this area. Because I have to teach you how to use the area of a polygon thing. And not all of these are going to work out like this. But what's this? You got 4 triangles here, right? So what if I took 2 of them out and flipped them over and kind of touched them together? So if I take this triangle here that looks like this with 8 and 8, okay, that's this triangle here. And then I take this one here, but I move it to the other side. We get 8 and 8, right? And because this was a rectangle, we know that this was a square. We know that these are 90-degree angles in here. So what shape do we have here?
Square.
A square. And what's the area of that square? 8 times 8, which is 64, right? Area equals 8 times 8, which is 64. And this is, how much did we do if we did both of those? We did half of it. So we get another one of those by doing those 2, right? So it would be 64 times 2, which equals 128 units squared. So now, don't expect them all to break apart that easily, but sometimes you run into one like this that you don't necessarily have to go through the whole formula the same way. And that brings us to another thing. If there's a more efficient way to cut something up, it's important to search out that way because, man, that took a lot less time. I mean, isn't that efficiency worth paying? I mean, doesn't that pay off right there? And this is what people get paid big bucks for. So when you get out and you start getting a job, you're going to get paid big bucks to look for efficiency in your job. So your job might be doing something over and over, and you find that, hey, if I hold off and do this one final piece to 5 units at once, instead of doing it for each individual one, I can save about a minute of time. But now let's multiply that by 100 workers. That's 100 minutes we just saved, right? And then if we do that every day of the year, you may end up saving your business a lot of money, okay? And so that is types of things that you're going to look for in life, is efficiencies like this, trying to come up with a quicker way, an easier way to get things done. Okay, number 17. Now, once again, they are asking us to use the area of a polygon. So that's where we're coming up with this 1/2 perimeter times apothem. We know what the area of a triangle is, and we can figure that out faster than doing this 1/2 area times apothem. But if you look, what's the next problem going to be? Yeah, hexagon. That won't be something I can do quick and easy. So we're doing the hard version on these simple shapes so that we can work our way into the hexagons. Okay, so what we need to find is perimeter. To find perimeter, I need to know the outside measurements. And so if I've got 6 and 12, then I want to know this length B. What could I use to find B? Pythagoras Theorem, so a squared plus b squared equals c squared, right? So 6 squared plus 12 squared equals, thank you for catching me, right, 6 squared plus b squared equals 12 squared. Yeah. So this is going to be 36 plus b squared equals 144. So that's going to be b squared equals 144 minus 36 is 108. So b equals the plus or minus, but we don't have to worry about the minus because it's length, root of 108, which is, now we got to figure out what does that break down into. So here's a question. Does 4 go into 108? Yeah, quit using your calculator. Does 4 go into 108? Well, you remember how to check for 4s? Cut 108 in half. What's half of 108?
It's going to be 54.
54. Can you cut 54 in half? Yes, you can. 27, right? So that tells me that 4 times 27 is 108. Okay, so this is root 4 times root 27. Jacob, can you step out? Are you good? Okay. So root 4 is 2. Now, can 27 break apart into any perfect squares? 9 and 3. Right. 9 times root 3. So root 9 is what? 3. So this is, right, 2 times 3 times root 3. So that's 6 square roots of 3. Good. So we know that b is 6 square roots of 3. So now, can we find the length of the whole side? If this is 6 root 3, yeah, this is also 6 root 3. So the total length is going to be 12 root 3s. So now I'm going to erase this big section over here again because I just don't have enough room to keep. Your page is going to be bigger, more work than what I've got here. I got to keep it all on the board together. So the area equals 1/2 perimeter times apothem. So the perimeter is going to be 12 roots of 3 and how many of those sides are we going to need? 3 of them. And then the apothem, how long was the apothem in this shape? Yeah, the apothem was the distance from the center to the closest edge. Which way would I travel to get to the side closest? Would I go all the way to the point to get closest? Is that shortest? Is that the shortest way out of that triangle? If you were in the middle of this triangle, like it's the Bermuda Triangle, and all you had to do was escape it, you needed to get outside the triangle, what path would you take to go the shortest way? South. Straight down. That's the apothem, right. That is the apothem right there. So 6 is our apothem. Yeah, what do you guys want to multiply 1/2 by? 6? Okay. So 6 with the 1/2, and that's going to be 3. So now what do you guys want to multiply together? You pick your order. It's commutative property lets us pick our own. Okay, so 12 roots of 3 times, and 3 times 3 is 9. So yeah, that comes back to the question is, what is 12 times 9? Well, 9 times, put that away. What's 9 times 10? 90. What's 9 times 2? Add them together? 108. Good. Oh, don't forget, units squared. 108 root 3 units squared. Now, if they ask you to round it, you guys know how to round. I prefer you to leave it as 108 root 3. All right, sorry, again, what's up?
What's the 108?
Units squared. Okay. So now we get into a little bit more difficult ones. So we've got number 18 here, which is a hexagon. But they've already given us the apothem. What's the apothem in this shape? 10 root 3. So the apothem is this distance here, 10 root 3. So now we just need to find the perimeter. How can we find the perimeter of this? Well, being that this is a hexagon, I'm going to cut it into triangles and say, what do I know about the individual triangles?
They're all the same.
They're all the same, okay. Because this is a regular shape, so how many degrees does it take to go around this point in the center? Okay, and when I cut that, how many triangles had I cut that into? Yeah, a hexagon divides up into 6 triangles, right? So, how many degrees does that leave for every angle? 60. You're right, 60. Good. And then when I look at this one, it cuts 60 down even further. It looks like it cuts it right here. It cuts it in half. So that means that this is a 30-degree angle right there. So I can use, let me just pull this. It's easier almost if you just pull these shapes out. So I'm going to pull this shape out and draw it again. This is 20. This is 10 roots of 3. Yeah, this is 30. This is 90. What does that make this corner down here?
Yeah.
That's 60. I could use Pythagoras Theorem here, right? I've got one missing side, B. There might be a simpler solution. Does anybody see a simpler idea? Okay, we could do Sohcahtoa. That might not be a bad idea. What else do you notice about these? Are they isosceles triangles? I mean, what were these angles here? This was 60. We just found that out down here, right? This was 60 then, and this was 60. What kind of triangles are these? Equilateral? They're equiangular, and if they're equiangular triangles, then they all three have the same size sides, right? A triangle is equilateral and equiangular. Yeah, B is 10. How'd you get B is 10?
Because they all have got the same size, and since it's cut down in the middle,
So you're saying all three of these sides have to be 20, and that one would cut in half, which is 10. You guys see that? This only works in a hexagon like this, okay, guys? So I don't want you to think you can do this with an octagon. The octagons are a little different. But yeah, because these are equilateral triangles, then you know that all three sides are the same. So if that's 20, then all three of them are 20. So let me erase all this mess here, and let's go back to this. Just go back to the basic. Whoa. There's me uploading your work. Okay. So we just go back to the basic picture. What do we know about all the outsides of this triangle, or this hexagon? That's 20. 20. 20. So, yeah, our perimeter is going to be 20 times 6, which is 120. So you guys take a moment and write out the area of this. Use the new formula and write out the area of this while I pause the recording. Okay, so you've taken a moment to do this, and you found that the area equals 1/2 perimeter times apothem, the area of a polygon. And so that's 1/2, and 20 times 6 was our perimeter, so that's 120 units. And the apothem was 10 root 3. It doesn't really matter which way you do this, but we'll do 1/2 of 120 and get 60 times 10 root 3. So that is, yeah, 600 root 3 units squared. Good. 600 root 3 units squared. Okay. So number 19 is a triangle again. But this time they only give us one side. So I'm going to pull this shape out. I'm going to pull this shape out again. And you guys want to get used to doing this. Pull these shapes out. And see if there's anything you know about this shape. Well, first off, if we look at the instructions for number 19, it says find the area in the perimeter of a regular polygon. So what do you know about the triangle if it's regular? Equal sides, equal angles. So this angle, and this angle are the same. That means they are each 60. That's right. So this corner should be 30 when I cut it in half. So that means this is a 30-degree angle here. And if I want to find the apothem, which is right here, if I want to find the apothem, I can call that A, and I'll call this B. Can I use trig to do this?
Yep.
Sure. We could also, if we knew our properties of a 30, 60, 90, what we're going to find is the trig's going to give it to us, but 30, 60, 90 has special properties that tells us A is going to be 5, and B is going to be 5 roots of 3. But let's use trig to figure that out. Sohcahtoa. Jacob, outside, please. Outside. So, Sohcahtoa here, 30, A is opposite, B is adjacent, and 10 is hypotenuse. So what could I use to find A? Sine would be opposite over hypotenuse, so that would be a good one to start with, okay? So sine of 30 equals opposite, which is A, over hypotenuse, which is 10. So multiply both sides by 10, and I'm going to end up getting A equals 10 sine 30, so A is going to equal 5. Sine 30 is half. And so A ends up being 5. Okay? What could I use to figure out B? You could use Pythagoras Theorem. You could also use cosine, or you could use tangent, now that you know A is 5. Okay? Either way gets you the answer. So let's use, Pythagoras Theorem. So A squared plus B squared equals C squared. Lots of people like this one. So 5 squared plus B squared equals 10 squared. So 25 plus B squared equals 100. So B squared equals 75. So B equals the square root of 75, which is equal to root 25 times root 3. So that's 5 roots of 3. Okay, or we could just get to where we memorize 30, 60, 90 is always going to look like this. Here's what a 30, 60, 90 is going to look like. Whenever I draw it out, it will always be 5, 10, and 5 roots of 3 if this starts as a 5. If this starts as a 6, it'll be 6, double 6, and then 6 roots of 3. So you could just call this A, twice A, and A roots of 3. Whatever A ends up being, you're going to get this same pattern every time with a 30, 60, 90. Just like a 45, 45 is always going to have two sides the same, a 30, 60, 90, you're going to get single, double, and then root 3 times the single. Okay, we haven't quite finished this one yet. I'm going to erase all this and just keep my A and B here. So, we said that B was 5 roots of 3. So this is 5 roots of 3 over here. A was 5. So yeah, that means that this distance here is 5 roots of 3. So the whole distance of one side is going to be how much? Yeah, it's double 5 root 3, so 10 roots of 3. And we know that our apothem was 5. So now we can get back to our area formula. So I'm going to erase a lot of this now. And let's get back to our area formula. 1/2 perimeter times apothem. And so that's 1/2 of 10 root 3, but there's 3 of those sides, times the apothem, which is 5. All right, what are you guys going to take half of? The 10?
Yeah, which is 5.
That's 5. And so that's going to be 5 times 5, which is
25.
times 3. 75 root 3 units squared. Thank you guys for being such a good class. And I will put the other half of this on 6th hour. All right, we're back with the 6th hour, 7th hour class, and we're starting on number 20. Now, on page, yeah, I said 669, but I think it may have actually been like 670 something. So keep on going, it's 11.2. Yeah, so it looks like it's on 672. I should have paid more attention whenever I labeled that. So number 20 says find the perimeter and area of the regular, the regular polygon. So on number 19, I just found the area and I didn't find the perimeter. So if I go back to number 19, I found that the area was 75 cube roots of 3 units squared. Sorry, square roots of 3 units squared. So to find the perimeter, and I'm finishing up the other one, you guys haven't seen this one. To find the perimeter here, it would be, well, it's basically, we've already done it right here. It's 10 roots 3 times 3 sides. So 30 roots of 3. Yeah, this is all going to be on YouTube. Okay, so, yeah, it's all on YouTube. You have to Google me. Before you leave today, YouTube, Google my name, search my name, DZ Conaway. There's not David Conaway, because there's like 5 David Conaways. But DZ Conaway, it's right there up on top. If you want to search it. Yeah. So, now we're back to number 20, which is a square. They did say these are all regular, so we know by being regular and 4-sided, there's only one option. It has to be a square. Now, you guys weren't here for the last square that we did, so I'm going to show you the hard way, and then I'm going to show you the easy way. Okay? So, it sucks, but it's what we got to do. So, for a square, we're going to try to use the idea of the area of a polygon, a regular polygon, is equal to 1/2 the perimeter times the apothem. Now, why I say the hard way first is because the hard way is meant for things like hexagons, pentagons, octagons, things that are bigger. Squares we aren't normally going to use this formula for squares. Squares are a lot easier to do just as the formula for a square. But if I look at the area of a polygon, I need to figure out what the perimeter and the apothem is. In this picture, what is the apothem? Is the 4 the apothem? We said the apothem was going to be like from the center, the shortest measurement, the distance to the outside edge. So if you were stuck here at the center of this square, and the whole square was starting to catch fire, and you had to get out, which way are you going to run that's the shortest route out? If you're at the center, which way are you going to run?
Straight down.
Straight down. This is the apothem. That's the apothem right there, okay? And so I'm going to, just for labeling purposes, I'm going to call this B. We're going to need to find that anyways, because once we find that, we can use it to find the perimeter all the way around this shape. And my buttons have disappeared. There we go. There we go. All right. So, how could I find this? Well, I have to come back to the idea that, well, this is a regular shape. And so I know that I can cut this regular shape up into triangles. And if I cut it into 4 triangles, then how many degrees would be around the center of this shape? 4. Well, it's 360 all the way around, right? But we cut it into 4 pieces. So how many degrees for each one?
90.
90. Good job. Yeah. So this is a 90-degree angle here, right? Because I'm going to cut it 4 times. And so if that's a 90-degree angle, and this one cuts that in half, how many degrees is this? 45. Okay? And that means that this is also 45. So I could use Sohcahtoa here. I could use trig to find out what A and B are. What would I use if I have A and 4? What would I use to find what A is? You're right. It's one of the 3. It's either so, ka, or to. So which one would I use for A and 4? Well, if we look at it, let's just call it that one right there. From 45, B is opposite, A is adjacent, and 4 is hypotenuse, right? So to find B, I could use so, right? To find A, I would use right? So for so, the sine of theta equals opposite over hypotenuse. So the sine of 45 degrees equals B is opposite, 4 is hypotenuse. So multiply both sides by 4. And I'm going to get B equals 4 sine 45 degrees. And put that in your calculator, tell me what you get. It'll be 2 root 2, I think. 2 root 2. Yep. Okay. 2 root 2. All right. Must be important to answer. So, anything else I know about this 45-45 triangle that would help us figure out the other side easier? Would you say that? Oh, hypotenuse theorem, maybe Pythagoras theorem, is that what you're thinking of? Yeah, I could do Pythagoras theorem. I mean, if this side down here is 2 roots of 2, and this was 4, and we already said that this was going to be 90, and this was 45, right? Can you tell me what kind of triangle we have here? What kind of triangles do we have? They are isosceles. Why are they isosceles? Because you have 45, 45, 90. And if they're isosceles, what do you know about 2 of their sides? They're the same. So if this is 2 root 2 on the bottom, then what does that mean this one over here is? Yeah, this is 2 root 2 because they're isosceles. Okay, so 2 root 2, 2 root 2, and 4. So now I've got the apothem. The apothem here is 2 root 2. Now I just need to know what the perimeter is. So if this is 2 root 2, from here to here is 2 root 2, then what's the perimeter around this shape? Well, how long is one side? How long is this side right here? Well, let's say this. How long is this piece? 2 root 2, right. Because the apothem does meet the midpoint down here, we know that these two are the same size. So 2 root 2 and 2 root 2 to go together to become what? Think of root 2 like a variable. Treat it like x. So say this in your head. What's 2x plus 2x? So 2x plus 2x is what? Is it 4x or 4x squared?
4 squared. 4 squared.
What do you guys think? Y'all all got to agree on something. 2x's plus 2x's are... So let's use a different word than x. Let's use dog. If this was 2 dog plus 2 dog, what do you got? Do you do 4 dogs squared?
Oh, it's not 4 squared.
So 2x plus 2x is... So 2 root 2 plus 2 root 2 is? 4 root 2's, right. So this is 4 root 2's across there. Okay, good. So now, how many sides do we have?
4.
4 of them. So we go top to bottom. That's 4 root 2, that's 4 root 2, and that's 4 root 2. So I know that the perimeter is going to be 4 root 2 times 4 sides. So that's right, 16 root 2. Good, and one thing to remember when you're multiplying is you always multiply the outsides of a radical with the outside of a radical. So the 4 times the 4, but don't multiply by 2. So now, to do the area formula here, 1/2 P times A, and I will be erasing some of this as we go because you'll be able to watch it on the video, but I don't have as much room as you do on your paper, so there we go. So the apothem times the perimeter, the A equals 1/2. Perimeter is 4 root 2 times 4, and the apothem was 2 root 2. And what do we get here when we multiply all this together? Well, what are you going to multiply a half times? You can do this kind of in any order you want. So what do you want to do a half of? A half and 4 is easy, right? That looks like the easy ones. That'll be 2 here. Okay, so 4 root 2 times 2 root 2 times 2. That ain't pretty. But let's do the 4 root 2 and the 2 root 2. Remember that outside things multiply outside things, and inside things multiply inside things. So what's 4 times 2? 8. Root 2 times root 2. Root 4. And then we still have our little 2 hanging out up here. So it's 2. Okay, so now whenever I multiply this out, what's the root 4? Yeah, that becomes, the square root of 4 is 2. So this is really 8 times 2 times 2. Well, no, this wasn't a square root over here. This was just a 2. So it's 8 times 2, which is 16 times 2, which is 32 units squared. Okay. And since you guys weren't here for the earlier one, I'll show you the easier way to do this. This only works because it's a square. I mean, there are other shapes that you could do these kind of things with, but we were doing this way to get ready for hexagons and octagons. So this is the polygon formula that'll work with like pentagons, heptagons, nonagons, all those things. So that's why we were doing it this way. But let me show you the easy way of doing this one. Let me lock this thing. So
there's an easier way to do that problem?
This specific problem there is, yes. Yes, because we were practicing to do harder versions of this. We were practicing with an easier setup. So it can be hard. It's kind of like whenever somebody makes you do finding the area of the wall with 10 and 20. Whenever you're actually, your walls are probably going to be like 10.764 and 20.385. They start with easy and then make it hard. So this one, though, let's see if we can come up with an easier way to do this. Since this is a square, we know that it cuts up into 4 triangles. And what do you know about these sides here? Yeah, these are isosceles, 45, 45, 90, right, triangles. So that means that this and this and this and this are all the same. So that's 4, 4, and 4. Now because of that, you see those two? I'm going to take that one out, and then this one. What kind of shape did I just make?
A diamond.
And that diamond has this as its outside. What kind of shape is that now? What kind of shape is it now? Yeah, it's like a baseball diamond, right? It's just a square turned sideways, right? It's a square turned up on its point. Is that easy to find the area of it? Sure is. And that is going to be 4 times 4, which equals 16. And that took care of this much of it, right? So what would be left?
The same thing.
The same thing again. So you get 16 again, and that would be together
36.
32. There we go. So that would be the easy way to find this. Now, like I said, we were practicing the hard way because, well, this. Okay? This was the reason we were practicing the hard way. So let's take a look at this one. It says they want us to find the area and the perimeter. So we're going to have to cut this up into its triangles. We need to find the apothem, which they already gave us, the apothem. And then we need to find the perimeter around the shape. So if 15 is the apothem, I'm going to talk about taking out one triangle. So go ahead and use your geometers, guys. You should be following along. Use your geometry to draw this. You can find a pentagon right there underneath the square. So start by drawing this shape. Try to locate the center and draw your apothem in and call it 15. And then after you're done, I want you to take out that triangle, and let's just look at that triangle. Now this is a regular shape. What did regular mean? What was that word regular? What did it mean? Sides are the same, so equiangular. Equilateral. Angles are the same, so equiangular. Okay, good. So if we cut this thing into 5 triangles, those triangles are going to be congruent to each other. And in doing that, if I cut it into 5 triangles, how many degrees does it take to go around that point in the middle?
360.
360. And how many angles did I cut it into?
5.
So what will each take off by? I think that was 5 going 72 degrees. So that's 72 degrees. So now, look what I've done to get the little triangle. What did I do to get the little triangle? What did I do to that 72 degrees? I cut it in half again, right? So this is how many degrees? It's half of 72. half of 80 is 40, so it's got to be less than that. Half of 60 is 30. So somewhere between 30 and 40. Yeah, it's 36 degrees, right. So this is also 36 degrees. Okay? So if this is 36, then from that angle, I want to find this bottom base B. Because if I find B here, then do you guys think we could probably figure out, well, that's going to be B again, and then I could use it to figure out the perimeter all the way around? Right, so if I can find B, I'm pretty much done. I just got a few more steps and I'm done. So what can I use to find B? Sohcahtoa. Once again, coming back to trig. Sohcahtoa. Now, I mean, there's no trick. There's no easier way to do this one. There's no easier way to do this one. So down here, from this angle marked theta, what is B? Opposite, adjacent, or hypotenuse? So it's opposite. What's 15? Adjacent. And I don't even care about hypotenuse because it's not really involved. So what one uses opposite and adjacent? Toa, right? Toa. All right, so tangent theta equals opposite over adjacent. So now I just need to rewrite this and say, look, tangent of 36 degrees is what theta was, right? This is our theta here, 36 degrees, equals opposite, which we said was B, over adjacent, which we said was 15. And how do we solve this problem now? Multiply both sides by 15. Proud of you guys. Y'all have really got that stuff down now. Okay, so 15 tan of 36 degrees. Okay, B equals 15 tan. I know, I don't know what.
Like in class, I'm thinking like, you sure? Saying what? It's not like he does like this camera. He always does that with and I'm like always in the hallway watching and I'm like, what? How do you do it?
I don't even know. I don't even know. I do it without thinking. But
I'm always doing that.
I can't do it without doing it without thinking. So so B equals 15 tan 36. What do you get? So 10.9, approximately 10.9 units. But rather than being approximate right now, I'm going to keep both of them because I might be able to just multiply and then do one rounding at the very end. So what would I need to do to find the perimeter of this whole thing? If I know that little b, what do I need to do to find the side? So multiply this by 2, because little b is one of them. So let me erase some of this. Okay. So I found that this is little b. I'm not even going to write it down because just 15 tan 36 is too much. But this also would be little b here, right? So together, this is twice b, right? That's 2 times b. So how many b's would it take to get around the whole thing? So this is 2 b's, right? This is 2b. You guys ever seen Romeo and Juliet? I love the opening sequence. You know when you do the opening sequence and they show their mailboxes? Do you notice what their mailboxes are?
No.
to be and not
To be or not to be?
I'm with it. I'm with it.
To be or not to be? That is the question. It's a famous line from Shakespearean plays. To be or not to be? That
So
is
that's
the
their
question.
mailboxes? Yeah.
Their mailboxes, you know, like 2B, 2C, 2D. Normally,
Oh, okay.
they had their mailbox was 2B and not 2B, which was also kind of a play off of their anger and their hatred for each other. One of them is saying, "If you're 2B, I am not 2B." Yeah. So, which I wasn't sure that was what happened. Yeah, I love that movie. It's a great movie. Yeah, I thought that, but I never did. I only watched it once. Oh, really? Okay. So I guess yeah. I need to watch that again because I love that movie. So this is 2B, 2B, 2B. How many did we say it was going to be all the way around? So it's 10 times B, but how much was B? It was 15 tan 36, right? So what's 10 times 15 tan 36? Well, no, don't decimal, right? What's 10 times 15? 150. So do you see how you can keep this? You can keep this really exact. So it's 150 tan 36s. Just keep tan 36 like it's an X. 150 of them. Okay, so that's the perimeter. Good. So let's erase that. Okay, good. So what else did we need? To do the area of a polygon, we needed the perimeter, which we already have, and we needed the apothem. The area of a polygon equals 1/2 perimeter times apothem. Do we know the apothem in this one? What's the apothem? 15. What's the perimeter? 150 tan 36. So let's do this thing. 1/2 150 tan of 36 times 15. Now, remember, this is 150 times tan 36. So I can take a half of 150 without dealing with the tan 36. I can leave that to the end. What's a half of 150? Yeah, so I can cancel those, and I got 75 tan 36s, 36 degrees, times 15. So what if I want to say, okay, how about the 75 and the 15 together? Right? So what's that going to be? Let's 750 plus 75 times 5, which is 15 quarters of 375. So 1,075? Oh, 1,120. Oh, that's close. So I was 50 off. So 1,125. I did this 75 times that 15. And then I said, oh, that's where I was off. I added 700 instead of 750.
Oh.
Okay, so 75 times 15 is 1125 tan 36 degrees. Okay, and now I can finally take that, round it, and give myself a number. So let's go ahead and round it and give ourselves a number on this. And let's find out what that is. .4 units squared. Okay, Now here's what I want you to do. Do me a favor and take 10.9 times 10 times 15 divided by 5. No, I mean round. What do you get?
Oh, wait.
You got 817.5?
807.
Okay. And now for us to see why this matters. Do you see what you got whenever you kept it exact the whole way? 817.4. What happened when you rounded off early? 817.5, right? Does that sound like a huge mistake? No. It depends on what we're talking about. If this was dollars, let's say that somebody was rounding up how much you wanted you were going to have to owe them. Would you care if they said you owed them $817.40 versus $817.50? Would that matter that much to you?
Not really.
Probably not. What if this was in millions of dollars?
Yeah. I don't care.
So $0.1 million is $100,000, right? And that makes a difference. We care about it then, right? So even though the mistake doesn't really show up until the fourth place value here, it's still a mistake, and it does show up. So this highlights the reason why we don't want to round early and then continue to work, versus rounding at the end like we did here. Rounding at the end is always better, especially when you get into something